From concrete to trowel takes a long time. At Lafarge, concrete is mixed by computer to the nearest gram. By studying the wide variety of concrete ingredients, Lafarge researchers have also been able to develop and mix them better. An understanding of the granular structure of concrete, that is, the way in which the ingredients come together, has enabled its water content and thus its porosity to be reduced and so make it highly resistant to external wear. Concrete has therefore become more long-lasting.
Strength. Research into the increased strength of concrete was the challenge of the 1980s. In fact, when you look at development curves for concrete strength from when it started up to the present day, we've seen incremental progress based on experience gained from construction sites. A little bit of tinkering, you might say, until about the end of the 1970s. Then, at the beginning of the 1980s, we began to introduce some science into concrete, to understand how it worked, why it was resistant, what were its weak points, etc. In fact, by going deeply into this subject, we reversed the curve. We started from a very, very high point and achieved levels of strength 10 times greater than ordinary concrete. And then we came to a bit of a halt, quite simply because the construction industry did not grasp such performance.
We're
now able to produce concrete of 200 megapascals in strength. That's to say roughly 5 times stronger than concrete in structures 20 years ago, and in the order of 10 times stronger than the ordinary concrete used in apartment construction, for example. So a strong concrete is long-lasting, and that's why we talk of high-performance concrete rather than high strength. It's both stronger and more long-lasting than traditional concrete.
Such durability and strength are of direct help to the worldwide society.
Durability is important for 2 reasons. First of all, financially. If you have a building that deteriorates, you have to repair and maintain it, which will cost money, stop you using it, etc. Secondly, there is a reason that's more closely related to aspects of sustainable development. If a building lasts for 100 years rather than 50 years, you're not going to have the same environmental impact with this building in terms of the materials that have been used to build it. Concrete is certainly the most long-lasting material that can be made. Today we're able to guarantee life cycles of 50 years, 100 years, 120 years, even 300 years. No problem. We have the tools, we know the processes for developing the material, and we know how to work with them. It's a material that in these conditions doesn't need any maintenance, and what's more, it's 100% recyclable. I believe that from the point of view of durability and the building's environmental impact, it's very definitely the material with the most benefits.